Today we're going to start graphing parent functions. There are 7 of them. Our learning goal for today is that you will know the basic shape and the key points for sketching each of the 7 parent functions so that you will remember what they look like and be able to know how to transform your graphs when we come back on the 20th. Our first parent function is the line, and the parent function is the graph that normally in some way incorporates the origin in some way. So the parent graph for a line, of course, going through the origin with slope of 1 is just the y equals x line. Or in this case, the function of x is equal to x. The parent function for the parabola is the base function. So we've done nothing to the quadratic formula. All it is the function of x is equal to x squared. So the vertex is the origin, and our step pattern or our a value is 1. And so it is strictly so for you to be able to graph this quickly, if you want to using the step pattern, that would be using the over 1 up 1, over 1 up 3, over 1 up 5, right? Using that 1a, 3a, 5a, 7a step pattern. This is the cubic graph. This is the first time that you have seen this graph. And so let's just talk a little bit about what some of the touchstone points of this graph are. And this one again goes through the origin. So you can see here it goes through 0.00. That's important. And then now we're going to look at the next whole number that we're going to look at, and that would be 1. And so when we put 1 into this, f of 1 is 1 multiplied by itself 3 times. Well, 1 times 1 times 1 is still 1. And that's what we get here. And then if we look negative, what is negative 1 times negative 1 times negative 1? It's negative 1. And so what I've got on this graph is just a way to try to help you see how we get from 0 to 1 and from 0 to negative 1. We'll just look at 2 simple fractions of 1/3 and 1/2. So when I take it, I just picked those 2 out of the air. So when we look at putting 1/3, so f of 1/3, 1/3 times 1/3 times 1/3 is 1 over 27. Conversely, negative 1/3 times negative 1/3 times negative 1/3 is going to give you negative 1 over 27. I do not expect you to try to find that point on a graph. It's just a matter of trying to show you the progression from 0 to 1 or from 0 to negative 1. And now when we go to 1/2, so 1/2 times 1/2 times 1/2 is 1/8. Just as negative 1/2 times negative 1/2 times negative 1/2 is going to give you negative 1/8. So our next that, like I said, that was just merely to help show you how we get that funny little swoop, if you will, between 0 and 1 and between 0 and negative 1. And so now we go and we're moving on through whole numbers. And so 2 times 2 times 2, of course, is 8. And often that is the only other point you're going to be able to fit on your graph. So your touchstone points are these, the origin, 0, 0, 1, 1, negative 1 and negative 1, 2 and 8, and negative 2 and negative 8. So if we just sort of pop those on the graph, we get 2, 2, 4, 6, 8. There we go. And negative 1, and negative 1, or sorry, negative 2 and negative 8. If you can get those couple of points on the graph, then all you need to do, because of course this graph, it has no restrictions on the domain or the range, as you can see over here. And what it does, however, do is it does climb very, very quickly, because negative 3 is cubed is negative 27, and 3 cubed is positive 27. Rarely are you going to get a graph big enough that you can graph all the way up to the 27th point. And so the key point of today for me, for you, is to get those touch points, get those quick points, and know what they are, so that when on this particular graph is 0, 1, and 2. Rarely when we are graphing these parent functions, to graph them quickly, we are usually looking right around the origin and often never much further away than 0.1 or 2 to get the base shape of the function. Our square root function climbs just as quickly as our quadratic function, just in the sideways direction. And of course, we're going to always have to restrict our parent function. It starts at the origin, because of course we cannot take the square root of a negative number. And since x will never be less than 0, y will also never be less than 0 on this parent graph. So have a quick look at the table of values here. Note how it's just the opposite of a quadratic, only the positive numbers. So we start at the origin. The next touch point, of course, is 0.11, because the square root of 1 is 1. Now, we very quickly move along the x-axis, because the next thing we have to get to is 4, so that we can get up to 2 over here. Sometimes you'll be able to get as far as over as 9, and then go up to 3. It runs off this graph, in this one in particular. Rarely are you going to get all the way over for your x value of 16 to go up to a y value of 4. Our next touch point, if we go positively along the x-axis, is going to be when x is 1, y is 2, because 2 raised to the exponent 1 is just itself. So we go over and up, and we're at 1, 2. Now, remember that a negative exponent does not make the number negative. All it does is make the answer a fraction, because anything raised to a negative exponent, what do? You take the reciprocal, invert it, and then raise it to that power. So 2 to the exponent negative 1 is actually a half. You can pop that into your calculator if you'd like to test it. 2 to the exponent negative 2 is a quarter. So you can see how my fractions are getting very small very quickly. 2 to the exponent negative 3 is an eighth. 2 to the exponent negative 4 will be a 16th. You do not need to try to graph those. All it does help you, though, is know that you're getting closer and closer to your asymptote of y equals 0. Conversely, you get off your graph very, very quickly. So your touch points on this are negative 1.5 is a good touch point when you're trying to just graph it quickly. 0, 1, 1, 2, 2, 4, and if you have room, you can go up to 3, 8. So those are your really quick touch tones, because when x is 3, that's 2 times 2 times 2, which is 8. When x is 2, that's 2 times 2, y is 4. When x is 1, that's 2 on its own. It's 1, 2, so you go. So do you see how you can climb very quickly on the right-hand side, and then on the left-hand side? The biggest touch point here is the negative 1.5, and then after that, you're just making your tail get closer to the y-axis without trying to touch it. This graph is new for you. This is called an absolute value graph. Everybody loves this graph. This is the easiest graph known to man. When we take the absolute value of a number, what we're doing is only looking at the quantity of the number and not the sign. So here, the absolute value of negative 3, you remove the sign, or you make the sign positive, and it's positive 3. The absolute value of negative 2, again, we're just looking at the magnitude of the number, and the magnitude is 2. So the absolute value of negative 2 is 2. The absolute value of negative 1 is 1. The absolute value of 0 is 0. And for positive numbers, the absolute value is the number. So the graph just makes a V, right? So this half, or this arm of the graph, is just your y equals x line. And this arm of the graph is just your y equals negative x line. But of course, only where y is greater than or equal to 0, right? There's no restriction on the domain, but the range, because absolute value is just about magnitude, it will never be negative for the parent function. This is our reciprocal graph. This one's another super fun one to graph. remember that we cannot divide by 0. And so for our function of f of x is 1 over x, 1 divided by 0 is undefined. And so those are our asymptotes. Our asymptotes are the x and y axis for this parent graph. And because it is undefined there, well, y is undefined when x is 0. It means that neither x nor y will ever be 0. Now, so let's look at the next touch points on this graph, the important ones. So the important ones are 1 and 1, and -1 and -1. And then, of course, because it's the reciprocal graph, if you have the fraction, so when x is -1/2, y is 2. When x is -1/3, y is 3. When x is -1/4, y is 4. So you're getting, that's why you're getting very quickly closer and closer to the x and y axis without actually touching it. Right? Because then as x, when you move away from 1, or you go to get larger than 1, it very quickly gets closer and closer to the x-axis because the y value gets smaller very, very quickly. So for speed graphing of this graph, because we're going to be doing some speed graphing next week or the next time you come back, your touch points, or if you will, your speed points are your -1, -1, and 1, 1. And then it's 1/2 and 2 and 2.5, just like -1/2 and -2 and -2 and -1/2. Those are the fastest points to just plot because they're easy to remember. It's just the 1s and the 2s. And then from there, you can just make your curve approach, but never touch each of the axes. And those are your 7 parent functions. When these parents have children, it is because these functions have gotten moved around the Cartesian plane. As soon as we move it from the origin, any of these curves, that is considered a child of the parent.